Welcome back to the Penny Math Teacher for part 2 on multi-step equations. So remember, our expectations are the same as all the other videos. These are your notes to your future self. When I look at an example and I show it to you and you're like, oh, I got this, great. But your future self in a week or two may not have got this as well. So make sure you're giving notes to your future self so you don't forget it. That way you can refer to them and you can practice along with your now past, present self. And then pause it, rewatch it, go back on your playback speed. You're using twice the video's length to take your notes and wonder about all the questions and all the patterns you're seeing. So make sure this is 20 to 30 minutes that you're dedicating to just watch this and pause and write and take your time on. Alright, so objectives, same as before. We're going to solve equations. These are special cases for our multi-step equations. So we are now on page 10. It's the part 2. So if you want to call it just part 2, that's fine. Or specifically, it's going to be variables on both sides and special cases of what equations could it be, what answers we could have. So make sure those are all labeled and headed up. And now we go. All right, and I'm going to use a red marker. So special cases are what we're going to start with first, and then we will do fractions 2 different ways, and then we'll end with variables on both sides. So we're going to probably start with most complicated, then work our way to a little more basic stuff. So special cases. This is all just where the mishmash of multi-step equations goes. Special cases. We're going to have 2, so A and B. I'm going to have 3 multiplied by the quantity x plus 2. That's going to equal 6 plus 3x. And I'm going to have 5 plus 2x equals x plus 6. All right, so if you want, pause the video. Try to solve these on your own. What do you end up with? So one way to solve equations is always guessing and checking. It's not the most efficient, but it does work. Other times we can just see it. X plus 3 equals 5. X has to be 2. So we're going to distribute this 3. We could divide by the 3, but distributing works typically the best. So I'm going to put 3x plus 6 equals 6 plus 3x. Okay, I'm starting to see something, but I'm going to keep going. All right, so I'm going to move my variables to the left-hand side. I'm going to make this go to 0, but then I have to do it to both sides. Okay, so I'm left with 6 equals 6. Wait, my variable disappeared. Does 6 always equal 6 no matter what? Yes. So that means my answer will be all real numbers. And in math, we have a fancy symbol for this. It's like the paragraph symbol in English, but it's an R instead. So you could put all reals, or you can write it out, all real numbers. Both ways work. Now, plug in numbers. Substitute in. What if we plugged in 3? If you plugged in 3 here, you would end up with 3 plus 2. That's 5. 5 times 3 is 15. Okay, left-hand side is 15. 3 times 3 is 9 plus 6 is 15. That's true. Okay, what about negative 1? Negative 1 plus 2 is 1. 1 times 3 is 3. Negative 1 times 3 is negative 3 plus 6 is 3. 3 equals 3. Any number you plug in, or you substitute in, will be a true solution to this equation. That's why your answer is all real numbers. The left-hand side is the exact same as the right-hand side. They will always equal each other. But conversely, we're going to have B. So, on B, I'm going to combine these like terms. Let's get these x's all combined. So I'm going to have 5 plus 2x equals 2x plus 6. I'm going to do the same thing. I'm going to make my variables go to 0, which ends up both of them going to 0. So I'm going to have 5 equals 6. Wait, but 5 doesn't equal 6. So that's a non-equals. So this equation doesn't even work. So in this case, there's no solution. The left-hand side can never equal the right-hand side. There's no x, there's no value that would ever make this true. So your answer can be no solution, or you can do the fancy symbol. When you do this symbol, make sure the slash goes all the way through the 0, because otherwise it'll look like a 0. Because some people write their zeros with a slash inside of it, so make sure this slash goes all the way through it and extends beyond it, okay? So those are our two special cases, and then we're going to have fractions, which we've seen some examples of fractions. These are fractions two ways. So we're going to do the same problem, but two different ways. Again, we'll have an A and we'll have a B. A is going to be using common denominator, and B is going to multiply by the LCM, which note that our least common multiple is typically our common denominator. You could have a different number for common denominator. The most convenient one, though, is your least common multiple. So both of these require finding it. You're just using it in a different way. So we're going to have 3/4 of x plus 6/5 equals 5/2 plus 1/3 of x. And it's actually the same problem for both of these, so I'm just going to write it now so we don't have to later. I think these headphones are made for right-handers, because if I was leaning this way, my voice would always come through just fine and clear. But now that I'm leaning this way, I'm talking away from the mic. Okay, because I'm a lefty. Woohoo! Go lefties. Alright, so for common denominator, I have a 4, 5, and a 2, and a 3. Okay, so what's a common multiple that 4, 5, 2, and 3 have? 4 and 5 make 20. 2 can go into that, but 3 can't. So that'd be 60. Let's see. 4 goes into 60. Yeah, I think it's 60. Alrighty. Maybe there's a smaller one. 24, but 5 doesn't go into 24. Okay, we'll go with 60. So I'm going to have this is over 60. This is over 60. This is over 60. This is over 60. Alright, for my numerators, 4 times 15 gave me 60, so 3 times 15 gives me 45. 5 times 12 makes 60. 6 times 12 is 72. 2 times 30 makes 60. 5 times 30 is 150. 3 times 20 makes 60. 1 times 20 is 20. So I have all these common denominators, and now I can just move everything around. Alright, so I'm going with variables on both sides, which we're going to do another example on the bottom that's more complex with variables on both sides, but you get to choose where you want the variable. It does not have to be on the left-hand side. It can be on the right-hand side. But since I have 45/60ths x over here, and I have 20/60ths x on the right-hand side, I'm going to subtract the 20 because that's going to give me a positive x value, so I don't have to deal with the negative, which is kind of nice. So I'm going to subtract 20/60ths on both sides. 45 minus 20 will be 25/60ths x. And I'm actually going to do 2 steps at the same time. I'm going to do it in blue just so you can see it. Since my variable is going to be on my left-hand side, I have to move the constant to my right. So I'm going to subtract 72/60ths from both sides. I'm making this go to 0. So note that these go to 0 and these go to 0. And that's why I know I'm adding or subtracting correctly, because I'm using the additive identity of 0. 150 minus 72. 150 minus 50 is 100. 100 minus 20 is 80. 80 minus 2 is 78. So I'm at 78/60ths. Boom. Okay. So I did 2 steps at once. I used 2 different colors so someone can still read what I did. They can tell that I did it 2 different ways, 2 different steps. And now I'm going to multiply by the reciprocal. Okay? And this is where simplifying is awesome. Alright, this one we know it's going to be 1. Easy peasy. Bring down your x. This one's going to be so 60 over 25. Yeah. Alright, 60 divided by 60 makes 1. Oh, 78. 5 doesn't go into that. So then we're stuck. 78/25. Ta-da! Woo! Alright. You could plug this in. Try to check it on your own. That'll be interesting. Okay, this one, we're going to multiply through by the least common multiple, which we used 60 over here on the left for method A, so I'm going to use 60 this time. Notice that everything is in parentheses, so everything gets a 60 distributed to it. So I'm going to distribute 60 to this 30, 60 to the 6, 60 to the 5, and 60 to the 1. All right? Now, you could write that out. For the sake of notes, I'm not going to write it out, though, because I want you to compare how much it takes us to do work for all of this. So if I was going to do this, I would be thinking, okay, 60 on top. What's 60 divided by 4? 15. So I'm going to have 15 multiplied by 3 with an x. 60 divided by 5. 12. 12 times 6. 60 divided by 2 is 30. I'm going to have 30 multiplied by 5. 60 divided by 3 is 20. 20, and I'm going to drop the 1 because I don't need that 1. 1s are invisible, okay? Now, we've seen these numbers before. Where have you seen 45x plus 72 equals 150 plus 20x? They're all the numerators from over here. So you're still doing the same problem. I've just now multiplied out, and I don't have that denominator to worry about. All of these denominators are just 1. So again, common denominator, but now the common denominator is 1, and now I can subtract the 20. I'm going to use my blue. I'm going to subtract 72, which, for our sake, we've already done this because we already know what the subtraction is going to look like. So those make 0, those make 0. That was 25. So I know it's going to be 25x equals 78. I divide by 25, so x equals 78 25ths. Okay, it took about the same amount of work. This one took more room just because you have to keep the numerator over denominator, but I'm using the same numbers, I'm doing the same math. I just had to either keep them with 60 in the denominator or get rid of that denominator in total. So think about which method you prefer and then just keep with that method. You can always practice or switch between both of them, but think about which one you prefer and stick with it. And then we're going to do a long one of variables on both sides. I'm going to write this in pen. Okay, so with variables on both sides, our goal is still to isolate the variable, which means the variable has to be on one side. It can be the left-hand side, it can be the right-hand side, which then means we also need to isolate the constant. So the constant has to go on the opposite side. I typically do the variable first, and I do a constant second. So I I'm not really moving. I'm making this go to 0 and then have to do it to both sides. But I'm moving it so that all my x's are all on one side and all my constants are now on the other side. I'm using those zeros to my advantage. Then I can solve it like a normal one-step equation. But I have to get all my variables on one side and all my constants on the other by using the additive identity. All right? And additive inverses, because they make 0, which is the additive identity, because I used the additive inverse of the opposite. Okay? So, I know, a lot of vocabulary. So, 3 multiplied by x minus 1 plus 4 minus 6 equals negative 12 plus 2. That's a 2 times x plus 3 plus 10. Pause the video if you need to write that down. Okay, I'm going to distribute first. I'm going to use a pen just because it's a little more clear, I think, in this instance. So I'm going to have 3x minus 3 plus 4 minus 6, negative 12 plus 2x plus 6 plus 10. I like to get rid of those parentheses and distribute everything first because now I can look at all the like terms. So this first step was to distribute. And distribution happens a lot, so I'm going to just abbreviate with dist. Okay, so I'm going to distribute first. Get rid of any parentheses or any exponents, all those weird things. You're going to get down to just your algebraic terms and your constants. I'm going to combine like terms next. So that's a constant, that's a constant, that's a constant. On this side, that's a constant, that's a constant, that's a constant. But notice, I can only combine expressions. The left-hand side is one expression, the right-hand side is one expression. So I can only combine these 3 constants together for right now. So I have negative 3 plus 4 is 1, 1 minus 6 is negative 5. So this is 3x minus 5. Negative 12 plus 6 is negative 6. plus 10 is a positive 4. So 2x plus 4. I could have put the 4 first. Put positive 4 plus 2x. Totally fine. So I've simplified as much as I can on both sides of the equation, and now I can figure out where I want my x's. I'm going to actually move to the right just because I can, so I can show you. Alright? So I'm going to subtract the 3x. That's moving it. I'm making this disappear and go to 0, so now it looks like I've moved my x over to the right-hand side. But I actually didn't move it because this is now a negative, not a positive 3x. Okay. At the same time, so I'll use my red, I'm going to, since I'm making the x's 0 over here, I'm going to make my constants 0 on the right-hand side. And again, I used 2 different colors so you can tell that I did it 2 different times. That's a negative 9 equals negative 1x. If you want to put the 1, great. If you don't want to, don't. Just put the negative because that has to stay there. And now, if you think about it, I can either multiply by negative 1 or divide by negative 1, and that will undo. I like to divide, but it doesn't matter. Those make 1, so x equals a positive 9. Woohoo! Yeah! So your goal is to isolate your variable and your constant, and then once you distribute and combine like terms, it's just solving like normal. I chose it, I isolated my variable and isolated my constant, and I solved it. So, yay! Alright, minimize that one. I know we went over 15 minutes. I'm sorry. But comprehension questions, they haven't changed much. Try it on your own, and have a great day. Thanks for watching.